Okay, getting back here, I did, when I walked upstairs to get a cup of coffee on the break, I did think of something I should have asked to begin with. Does everybody go by the name showing on the screen? Mia and Brandon? Did I say your name correctly?
Yes.
Okay. Okay. Yeah. Sometimes it's hard to keep track of what everybody goes by, especially with the Zoom calls. Everybody's names wrote there. I know it keeps happening to me on Friday night because one guy goes by his middle name and his first name's really long. So like the initial is there, and I keep calling him by the first name that's wrote out. And it's like, oh, I know what he goes by, but I always like to make sure about that. So getting started here into server-side scripting. I guess the first one, kind of obvious topic header here, the background and history. Just a quick pass of this, let it, so you know where we're there. So the expectation in here is, because of the prereqs, is everybody knows some programming logic, right? You've had at least the SDEV 120. Having the SDEV 140 would be nice as well, because then that's another semester-long practice, detailed practice of the logic. You know, like in 140, you spend 5 or 6 weeks going over each thing. You know, you study variables, and you study selection structures, and you study while loops, and we're going to look at all of them, all those in one lecture. It's actually the second set of lecture notes, so we might even get started on it this afternoon. But we'll zip through that course. So hopefully everybody's had at least SDEV 120, maybe SDEV 140, so that you're somewhat familiar with the programming logic and you know how to make sense of a selection structure and when to set up loops and the scene arrays and things like that. Obviously HTML and CSS, the SDEV 153 class, that one is a strict prerequisite for this class. I don't think you can take them at the same time. But you know how to put together the HTML tags and style them with cascading style sheets to make them look nice. Also, I believe something using SQL is a prerequisite as well. Structured query language. Which one thing
probably DBMS 110.
Okay, yeah. I couldn't think of the letters. I knew it was 110. But yeah, thank you, Joe. DBMS 110 is a prereq, so you use seen SQL. And one thing I've noticed in other courses that I've taught is when people have only had that class, they think there's a slight misunderstanding. SQL is an entire category of languages. It's not a single language. So the SQL we might be, the flavor of SQL we might be using may be slightly different than the one that you know. We'll be using MySQL, but MySQL comes in 2 major flavors. When the guy created it, he made 2 of them and named them after his daughters. One of them is MariaDB, and that's the expensive one that costs a bunch of money, and you may have seen that one. Or he also made MariaDB at the same time, which is a free version. So even MySQL has 2 different versions of it. So SQL, structured query language, is an entire family of languages. It's not just a single language. When we get to that, I will try to point out a few of the things that you can often look for to try to narrow down which version you're looking at if you're not familiar with. There are some things, because they're all very, very similar, so those differences are to look for kind of hidden, but some things you can notice, like a whole lot of them write the word auto increment differently. That's one of the first ones to look at, and we'll see that when we get to SQL. But hopefully everybody's had those and is somewhat comfortable with them. We'll do at least a quick review on each, and please ask questions if they show up. As they show up, then as they show up in class. Feel free to holler up if you have a question. You notice I have my chalkboard. This is my gym. This is where I do my math at. So a lot of times I'll be standing up here making notes, and I might not see that little hand symbol that Zoom has, or I might not see something pop up in the chat room, especially like today when there's already a bunch of stuff in the chat room. If one more thing shows up there, I might not notice it until I actually get back over there and sit down. So if you have a question, and when you have a question, just hit unmute and interrupt me, because that's definitely the best way to get my attention on a Zoom call if I'm standing over here. Let's see. Hopefully you had those. This course, we're going to look mostly at PHP, server-side scripting, and we'll be what we're doing is writing scripts to apply the programming logic, also known as algorithms, and mostly to connect SQL results, maybe some files as well, but some sort of stored data back to the HTML CSS page for the users of the internet. We will be using relational databases. There are also non-relational databases. That may be a good one to look into whenever you have, whenever you go select things for that new technology report. Or there's a discussion board where we will talk briefly about relational and non-relational databases. Relational databases are where we store all the data in tables. Every table has named columns. It's all stored in the same order. We'll put foreign keys and primary keys, and some the columns from our tables will show up as columns in other tables too, to connect all the data together. And that's a relational database. We'll see those, I believe, in week 5. We'll go over that, but hopefully everybody's seen that before. But PHP does work with non-relational databases as well. It doesn't have to be SQL. That's just the ones we will be using. And we'll be looking at this in internet-based things. But one thing I want to express clearly is this isn't solely an internet thing. Server-side scripting is a networking thing. And so there's a lot of the concepts that we'll be covering, more so the stuff on the board and the logic behind what we're doing in the examples. That's for networking in general, large or small. Anytime a server and client communicate with each other, which is showing up more and more in IoT things, right? Internet of Things. We might need to communicate with our coffee maker from the phone, but the coffee maker really doesn't need HTML code and CSS code. But the way that we would, have our phone send a message to a server, and then that server send a message to the coffee maker, that is still applying server-side scripts. So the logic we'll do here also applies to there. I might try to work in some simple IoT things. At the very least, I'll go, at some point, we'll jump over to GitHub and I'll pull up my starter IoT files and we'll look at those. My starter files are wrote in for IoT stuff are written in PHP. So at the very least, we'll look at those. And also on week 6, when we look at AJAX, that's asynchronous JavaScript and XML. The short version of it is that's where we update a web page element by element instead of an entire page. Instead of redoing the page and reloading it, we will just update element by element, HTML element by element around the page. We'll look at that in week 6, I believe. And our textbook uses jQuery for that, which has a pre-built function. And we're going to not do the pre-built version. We'll do it in pure JavaScript because the logic of how that goes applies no matter what language we're working with. Anytime we communicate with a server, it's that same logic. So I wanted to look at that directly instead of the pre-built function like the book uses. But while we're looking at this stuff in terms of a website, at least try to keep in the back of your mind that this is network communication. It's just the internet and websites are the most common network we see, and a lot of smaller networks are modeled after them. But the logic of what we're studying in this class will apply anytime we need a client and server to communicate with each other. This is how we put those scripts together. And the MySQL databases and HTML pages are just the example of how we're going to study that. The application of how we're going to study that logic. So some background stuff, history. You're probably familiar with some of this. I guess I'll start with some protocols here. So I want to get a picture up here at some point. Because of the prereqs, this probably showed up in the prereqs, but the internet as we know it, the internet, the World Wide Web, got started back in the 1960s. The height of the Cold War, a looming threat was mutually assured destruction. The United States and the Soviet Union just kept building more and more weapons, and mutually assured destruction was a big threat at the time. The U.S. government asked some researchers to come up with a communication protocol that could withstand mutually assured destruction. And what they came up with is called Internet Protocol. And the basic idea of this, and this is the picture I'm going to expand in a minute, is maybe we'll have a bunch of sites around here. That's probably good. We have several sites that we want to keep communication channels going after mutually assured destruction, after the doomsday scenario was a concern. Well, beforehand, it's not a problem because we probably have communication channels all over the place, right? This site A connects to every single one of them, as well as all these others are going to connect to every single other site. There's a channel, some sort of connection from each one of our sites to every other site. And the idea of Internet Protocol is we basically just check the signal, check the line to see if it's open. So maybe for our example here, maybe we want site A needs to communicate with site E. What it's going to do is it's going to send out a broadcast, a ping, to every machine it knows about. And the first machine to respond is where it sends it. It's like, okay, so that if some, back in the mid-1960s, they were worried about nuclear bombs going off, some bomb came up and destroyed all those channels, A can still get a message to E by checking every communication path it knows about, and then sending it down the first one that it knows is open. And then that next one will know that the destination of that message, so it too is just going to check every communication channel it knows about and send it down the line. And eventually it'll get to E, hopefully without much backtracking or things getting lost. But the basic idea is every site just checks every possible communication line to see which one's open and then uses whichever one's open. And to make it easy, it's usually generally just the first one. The first one to respond, we know that channel's open, so it sends it that way. It kind of worked. There's a lot of overhead involved in that. And there might be some big data packets, and things can change, and big data could clutter that up. So before too long, there was another protocol come along, Transmission Control Protocol. And we're just doing the very stripped down basic version of this because this isn't a network class. We're working with servers, but it's not really a network class. And the idea of TCP is to break data into chunks. Break data into independent chunks. And That way we have a bunch of small chunks of data instead of large communications trying to go down the line. So IP, the idea was check every line and send wherever, send down available. So these two protocols, they kind of covered different things. These chunks are referred to as packets, would be the technical name for them. I guess I should put that up here. We break our data up into small packets that are all independent and can be, and add a little bit extra to them. In particular, enough extra data that we can put them back together on the other side. We know what order they go in, how many they're supposed to be, and enough to put it back together. So the picture for this is like, so we have some piece of data, document or something, and we can just randomly break that up into different size pieces and then send each piece independently and put it back together on the other side. So when we put those two together, we end up with something very, very reliable. We have small chunks of data from the transmission control protocol, all traveling independently through a network, so that we should always be able to find an open line to send that packet. And that gives us a reliable way. There's some basic data, checking in there, usually just checksums and stuff, enough that we can tell when the data has been corrupted. Maybe not catch everything, it's not super fancy, but some basic error handling. We have small packets of data, so we don't overwhelm our network with trying to do huge transmissions at once. Every packet can travel independently down different lines, right? So communicate from A to E. Some packets might go up through B over to D and then back down to E. Other packets might just take the straight route through. Some might hit every other site on the way through, but they're all traveling independently. And when it arrives at the other side, there's ways to put it back together. That's the quick stripped down version of those. And obviously, this one's going to have a lot of overhead involved, because we have all these little packets and we have to have information about what order do they go in, some error correcting, some checksum bits and things. So there's some overhead. But by the 1980s, pretty much the average machine and pretty much all the cables that were in use could handle it. So since then, it's been virtually the standard because it's easy and reliable. There are things that might be more accurate. And we have these checksums. Like, anybody ever waited on a web page to load? And you're sitting there waiting, and the thing's just spinning and spinning and spinning, showing that stuff's coming back. Usually that's an error happened in transmission. So it's just something went wrong, send it again. We send these packets, tries to assemble it on the other side, detects an error, it's like, oh, something went wrong, send it again. So most of the times you've sat and waited on a web page is probably just the protocols going, something went wrong, send it again. Something went wrong, send it again. Something went wrong, send it again, over and over and over again. So there's that overhead, but we don't worry about it too much, because communication around Earth is still fairly, still going to be really quick. Right? We wouldn't want to do that on, like, say, that satellite camera that we sent to Pluto. Because something went wrong, send the data again is completely unreasonable if it takes, I think we're up to 13 hours, almost pushing 13 hours for the communication to go each way. So send it again is completely unreasonable there, but around Earth, it's fine. And it's a nice, reliable, easy way. If anybody is heading to a 4-year degree after this, in most 4-year computer science programs, you'll have to write this protocol. Like I know at IUS, over there, they will have an example either in the textbook or they'll print out an example where this protocol is written in C and they'll have you write the protocol in Java. So it's a standard thing for people studying 4-year degrees. It's quick and easy, and it's usually a weekly homework assignment. It's not even a big project or anything. It's like part of a homework assignment each week. So quick and easy and reliable. So once the equipment could handle it, really the cables, but by the time the cables got there, the average machine could handle it as well. It's been virtually the standard since then. Quick and easy. Whereas in this class, so these sites I marked here with the letters, the A, B, C, and D, those are servers. Those are servers that can communicate with each other. So really, off the side of that server, we're going to have another little client. I'll draw that. So that's my little picture. It's supposed to look like a laptop. I'll probably draw that quite a few times this semester when describing the logic. I didn't actually draw the server picture. We'll see that before too long. Well, the server picture is like a rectangle. Looks like a desktop thing. I guess anymore, most servers go horizontally, but I still use the vertical diagram when I put them up here. So here's my picture for a client. And so this is server-to-server communication. It also applies to this client-to-server communication, but this is the area that concerns us. I'll put another one over here. So off that server that's tied into all the big communication lines, there's also a client. And the whole point of communication is there's a human over here, right? We want to get the communication human to human, and the machines are just what we use. So these are the areas that concern us: the server, the client, and the end user. That's kind of what we're looking at in this class. The scripts that we run on the server to dynamically change whatever came across all of this channel, any last minute dynamic changes to reach the client in order to communicate, for the communication to get to the user. And yeah, then inside of that little circle I drew here of what concerns us, servers and clients require different kinds of scripts to run on them, and they are not interchangeable. Server scripts will never reach the client, only the result of the process. So the scripts we write in this class will run here, and then we only send the result of all the processing back. So when we're here on the client, we can't even see the script. We can't even see the scripts that ran. For the most part, server scripts can't even run on the client. That's why we have to install either some sort of local host virtual server to test with, or set up an AWS account, or set up a free, some sort of free domain hosting site. Those who have me in the HTML class the first 8 weeks, that domain hosting site we use, we can run PHP. Pretty much everything that we're going to do in class we can do on that site as well. If you want to use that one for some test environments, and sometimes it's good to have multiple test environments. For other people, whenever we get to lab time today, if you want to stick around for a minute, I will tell you what site we used and stuff for free domain hosting in the SDEV 153 class the first 8 weeks. It's easier to get up and running quickly. A lot of the domain hosting these days, AWS is not in this bracket. It's set up to accept WordPress sites. That's WordPress is a common content management service, CMS site. Ultimately, what we're building here, the idea is it's a different way of processing this. We'll talk about that later in the semester. But WordPress uses PHP and MySQL to put together the HTML pages. So most domain hosting sites are set up to run PHP and MySQL and everything we're going to study in this class right out of the box, which makes the free domain hosting even easier. Then the AWS accounts, we'll get those set up on Thursday. But we will need a server somewhere to do all the stuff this semester. And for the class examples, I'm going to use that localhost server. And even if you have even if you have multiple accounts, it can be kind of nice to test things locally and not have so much uploading and back and forth testing and jumping between environments. But somewhere or another, you'll need different ways to make, you'll need a server to run all the scripts on. So XAMPP and AWS are probably the main ones we'll use. The other one is this free domain hosting site I've used a few times. Used it the first 8-week class. It'll run almost everything we do in the class. There's one example near the end that we'll put together a chat room. And I don't think we can do the chat room on free domain hosts. And that's like most free domain hosting sites won't let you do a chat room. It kind of overwhelms their servers. They won't let you do it on the free accounts. You have to pay for the accounts that can handle a chat room. But everything else, we will, any free domain hosts will be able to use. So those who weren't in the class with me the first 8 weeks, I'll point you towards this one I like to use. The big thing about it is it shows ads to the programmer. So we get a whole lot of things that other sites would make it, other domain hosts would make us pay for because they show ads to the programmer. And I'm used to seeing, it doesn't bother me because I'm used to seeing ads. So it's nice to have those extra features on there for free. But back to server-side scripting. There are a lot of languages that can do this. The PHP is probably the most common, especially since the days of WordPress. Well, I didn't mention, that's the second time I mentioned I should talk about that. So CMS, content management services, ultimately that's what we're trying to build up. If you're in this curriculum, taking the SDEV 153 class, the 250, and in this class, it's building up to that. And the main idea of them is we never put together an entire page. Like you probably remember in the SDEV 153 class, creating that file that had all the HTML code for the page. And then you'd transmit that page across the internet. When you load it up, scroll around and look at it. So CMS sites are much more efficient. We never build the entire file. What we do is we take all our HTML code and usually the other PHP scripts we want to run and JavaScript scripts we want to run or whatever language we're working in. And we put all of that code into a database. So then when somebody goes to the URL for our page and types in the address for our page, we don't actually have a file to send them. What we do when they go to the page is we run a bunch of database queries and they get enough of the stuff from the database that it looks like the page. You can often recognize these. You've probably seen it on blogs before where you load up the page, load it up, and it looks like everything's there. And you see ads flashing all over the place and the words are there. And you're reading through the blog, and then when you go to scroll down, there's a pause. Nothing happens. It's like it's stuck. And that is usually an indication that it came from a CMS site, WordPress being a very popular one. And before sending that HTML code to display in the browser, the server asks your machine, the local client, how big is the screen? And then it only retrieves enough HTML from the database to fill up that screen. So as soon as you scroll down, it had to start that whole process over again, which cuts out transmission rates a lot because then we only need enough to fill the screen at one time. We don't have to send the entire file immediately. There's a lot of advantages to it. And ultimately, we're building up to that. Like I keep mentioning WordPress. That's probably the most popular. But WordPress is a generalized one. It's the one that is set up to have all the features available so that anytime people need to do something, they can jump on there and have all those features. If we know what the job is and just use that format, we can cut out a whole lot of the overhead that comes with all those, all those features that we'll never need. And do just the stuff needed for that job in that more efficient format of a CMS instead of the HTML files and CSS files and .js files and .php files and all those big complete files. We just run a bunch of database queries, and all of that code is stored in the database, and we just retrieve it as needed. So ultimately, we're building to that, and WordPress is the most common, and they use PHP and MySQL. So that's why we study it in terms, while we're studying it in terms of PHP, as opposed to Python. Python's a terribly inefficient language, but everything about Python is to make it easier on the programmer, which makes it really nice in classrooms because then it's a lot easier to study the language, study the logic when we have a really easy language to work with. But we're looking at PHP, and yeah, it's a machine. We can make any language, just about any language we want run on it. But we'll be looking at PHP, which was first developed around 1994 by the guy's named Rasmus Lerdorf. Is that our? Yeah, sorry, I have a really messy handwriting. By Rasmus Lerdorf, and it was for his own web page. He called it personal homepage. That's what PHP originally stood for. So in 1994, Rasmus Lerdorf created personal home page. And basically, he set up a server to run C++ scripts to make his HTML dynamic. That's the sense of what he did. So, in a lot of aspects, if you've worked with C++ before, everything we're going to do is going to look familiar. It was originally just he was running C++ scripts to make his page dynamic. Well, the way he did things was a really nice way. Other people took notice of it. Eventually, it became an organization, and now it has a recursive name. It stands for PHP Hypertext Processor. Yeah, there's a number of things named this way. I'm not a big fan of it, but notice that the P stands for the whole language again. So it's supposed to be like it's kind of like an infinite loop. You just keep writing that name over and over and over again. There's a bunch of things that got named that way. I'm not really a fan of them. But PHP Hypertext Processor is what it's called these days. And it evolved naturally. There were no formal specs until 2014. I guess I should put that date on there. So from 1994 until 2014, there was just a bunch of programmers around the world doing this. As a result, lots and lots of programmers created lots and lots of functions to be included in that formal specification. And that's the big power of PHP. For 20 years, programmers all over the world were using this same syntax and compiler and C++ compiler to do this. So it built up thousands of functions, thousands and thousands and thousands of functions just in the official library. And then there are unofficial libraries. So the nicest thing about PHP is after all of that, even by the original 2014, when they first started formalizing it, is there were so many functions, it would be very, very unlikely if what you needed to do wasn't already included in a function. So there's the stuff we want to do is already pre-built for us, is the nicest thing about it. Most of what we would do on a web page is already built into a function. All the things we need the script to do, we don't have to go write our own functions. We don't have to build up huge libraries. There are huge, huge libraries, like thousands and thousands and thousands of functions. Way more than one person's going to remember. So let's look at the list. So I'm going to share my screen here and pull something up. So the official reference is at php.net. And you'll want to keep that address in mind. A couple things I want to point out here. Right here at the top, on March 4th, a couple weeks ago, PHP 8.0.3 is released, and PHP 7.4.16 was released on the same day. So there are two different versions going on. We will be looking at stuff in PHP 7, though this is an introduction to PHP class, so pretty much everything that we're going to look at has been around for a while. We'll see a couple things that were new to 7, but for the most part, it would even go back to the older versions. So we'll be looking at PHP 7, and there's all sorts of documentation here. I'll kind of click through and find something. Yeah, I want English. Yeah, so I'll just click on the list of functions, and there's this huge list here of oh, that's not what I was. That's for pre-built. So official documentation, and one thing about the PHP documentation is at the top of the page is the stuff from the oversight board that sets all the standards for it, now that there are formal specifications set for it. And on almost every page, if you scroll down, you'll get to a chat room where other people and a forum where other people have just posted their experience with it and have little tips and clarifications, which makes it a little nicer than the average API. But you want to keep this one in mind, because languages are dynamic, they change, right? Back on that home page. Just at the beginning of this month, there was releases on version 8 and version 7, and it wasn't the first release of either one. So there were releases on both of them just this month. If we scroll back, well, the previous release was the previous month. So we can probably expect the release next month again, right? Languages are dynamic, they change. So one thing you always want to keep an eye on is the date of the information. So I said, remember that address, php.net, but that's not what you're going to do, right? You're not going to type that in. Something that's coming up soon. You can go to Google and type in some question like this, right? Integer division in PHP. I could have spelled that all out. I knew the name of the function. And then you want to look for that official API. So always look at the API first. W3 schools will have, if you're familiar with those, using those before, they have their all that reference material, like the HTML and CSS. Geeks for Geeks, I like their tutorials. I've used a lot of their tutorials, but sometimes they're loaded down with advertisements, like the annoying advertisements that pop up in front of the page and make you wait for 15 seconds. But after that's gone, their tutorials are kind of nice. But keep the official API in mind because that's the one that's always going to be up to date. What's showing up more and more is for years, people have been going to Stack Overflow and sites like that for everything. It works. It's a good place to look. You'll see the forum, the discussion. Usually you can tell if the post is coming from somebody that knows what they're talking about or not. You often have to be careful with it. You know, it's a public forum where people are just talking about the language, take it with a grain of salt. But the thing about that is that's been around for a while. That's starting to be around for a while. That's been around for a lot of versions of the languages. And I'm starting to see that more and more lately. Is now that it's been around for a few years, people will go check Stack Overflow for something and grab something from like 2012, which might not be the current version. Right? We'll be doing PHP 7 in this course, but maybe you go to Stack Overflow and see a solution to your problem that was the solution in PHP 4 years ago. It was a long gone solution that is no longer valid because the language has changed and dynamic. It's happened quite a bit. I've seen it a lot with Python lately because it was just a couple years ago that the main switch from 2.7 to 3 in the Python language happened. So a lot of the top results on Stack Overflow are still talking about Python 2, but we're mostly using Python 3 these days. So whatever reference material you go to look at, just remember to check the dates. Official APIs will be up to date. You always want to look at those first because that's the current, most valid information. But if you look at other things, make sure you check the date. Make sure it's up to date information on it, because that is becoming more and more of an issue these days, as those public forums have been around for a while. Y'all might remember from the SDEV 153 class, one of the items on search engine optimization is links to a site. So forum posts that have been on that forum for longer, other reference material might link to that. So they're going to have more links and score higher in the search results. Or things like Stack Overflow, I can't remember what they call it on their site in particular, but the thumbs up or thumbs down button, right? The like or dislike buttons, everybody gives those a different name, but the thumbs up and thumbs down buttons, those are going to affect the results. And when they put them in, when they go and organize them, the computer algorithm is only going to look at how many likes a certain response has. And it's not going to look at the date. But obviously, something that's been there since 2012 is going to have a whole lot more likes than something that was posted in 2021. So just make sure, and not just for PHP, but just anytime you're looking stuff up, keep an eye on the date. Make sure you look at the date of that reference material as closely as you look at the reference material itself. Because some things are, they've been around for a while, might be starting to get a little out of date. I have one more section to write up here on the board. Is it okay if I erase this part over here? For those who haven't had me before, I'll assume the silence means it's okay. For those who haven't had me before, I always try to ask before erasing something from the board. Because I remember sitting in many classrooms when trying to keep up on notes or something, and then the board would suddenly be erased. Or the absolute worst, when the lecture continued while the board was being erased. So then there was just a gap in what actually made it onto the board. So I always try to ask before erasing stuff. let's see. So originally, it was C or C++ command line. That's why Rasmus Lerdorf developed, if I'm pronouncing his name right. I hope I am. But a C or C++ command line sort of interface. So that means we have the general syntax of a C family. Has anybody worked in the C family of languages before? I don't hear any responses. I know the SDEV 140 class always does or for several years now has been doing Python, which Python was to break away from some of the troubles of this. We lost tons and tons of efficiency to make it easier for the programmer. But machines have gotten faster, so generally we don't worry about putting extra work on the machine. But we'll have to use some of that stuff that Python stepped away from. So if you've seen that, I think the 140 class also uses Visual Basic, which is an outgrowth of the BASIC language, which came from the early 60s, and the B in BASIC stood for beginner. It was developed by a college professor to teach his first-year students how to program. So it has a lot of easy features to work with too. So may have to get used to a little bit of that, but a couple of things we have. Actually, I asked that question, and I had a note here. I had a note to the side here. Ask about the C family. You have worked with the C family. Cascading style sheets, CSS, those are C++ structures. In the engine, it's mostly Chromium anymore, now that Edge has switched over. But in the engine, the actual browser, there's a selection structure. There's a big if-else thing. It's like asking, if the next element is maybe a paragraph element, then the condition inside that block is just says go see if there's a structure for paragraphs. So CSS is a C++ structure. It just doesn't look like it because we leave out a whole lot of the other things, and a whole lot of the things are put in the background from when we're just working in C++. If we're working in just CSS instead of C++, it's just a piece of it. But we have those semicolons, which means end of instruction. So every time we finish telling the machine to do something, one step at a time, right? Machines work with binary, the ones and zeros. That means we can either do something or not do something. So we have to take every instruction, comes in one instruction at a time, and every instruction we have to end with a semicolon. We have to put the end of instruction character there. We also have curly braces. And curly braces segment off a section of the code. And then I'm running out of room here, so I'm just going to write all these together. The if, while, and for syntax. We have the same type of if selection structures. I might as well put switch there as well. If, while, for, and switch. So switch is a selection structure like if. We'll see those soon. And then while and for loops, we have that same C++ syntax. And the curly braces group together our instructions. So every instruction ends with a semicolon, and curly braces put groups of instructions together so that we can run conditions for like an if or a switch, or have set up loops with which instruction is going to repeat. We'll see this in much more detail later. This is just kind of a brief overview here. The big thing that's different from the rest of the C++ family, and I was using stars here for this little bulleted list so I could put a bunch of stars here, is PHP is loosely coupled. Need more talk. Whoops. PHP is a loosely coupled language, not strongly typed. Anybody have any idea what those words mean? I put 3 stars here to indicate it's important. Is it okay if I erase this next little section here? Anybody need me to wait before I erase that? I'm going to go ahead and erase that. So strongly typed, you're probably familiar with. I think in the SDEV 120 class here, even though most of them use Raptor when learning the basic logic of programming, and Raptor is open typed, meaning we don't have to say what type we have. Most of the instructors go ahead and treat it like a strongly typed language, where we go ahead and declare our stuff, right? We have to say what we have. If we're going to work with an integer, we have to specifically say we have this integer called x, assign it the value 3, end of instruction. And we have to say that's an integer. And it can only be an integer. We cannot go back and change it because the computer only set aside enough space in memory, over in memory, to store a whatever, probably 64-bit integer these days. We can't change that. Open typed is like Python. So, then a couple lines later, if we tried to say, in this example, if we tried to say x equals words and pass in a string, we're going to get an error because that's not an integer. The compiler's going to throw an error in a strongly typed language and be like, oh, wait, word, that's a string, not an integer, cannot store that in x, in the variable x. Open typed is like Python, where we don't have to say it's an integer. Just to say, okay, we have this variable called x, stick a 3 in there. And in Python, we don't need the semicolon. And that'll store 3 in there. We'll go through the code, we finish what we were using in that. It's like, okay, instead of creating a new variable and leaving some stuff hanging out in memory, wasting space, now we need a string. So let's go ahead and put that string into x this time. Well, that's fine in an open type language because we never said what kind it is. We might have to deal with casting. We can't try to do math once we have a string in there. But we can change back and forth. We don't have to say what it is. We don't have to do fancy stuff to switch back and forth what we're storing in that little spot in memory. That's an open type. Loosely coupled means we're basically going to treat everything the same. But the loosely stands out. So we're dealing with websites here with PHP, right? Personal homepage. From the beginning, it was set up to be a homepage to go with HTML. Right? This was shortly after the development of HTML, if you remember that from the history section of the other course. That means text and graphics. In particular anymore, that means Unicode. So we're going to try to treat whatever we have as Unicode. And then if we need to do some math with it. We'll see if we can turn it into math. We'll see if we can turn it into a number and do math. If we need to print it on a screen, we're trying to treat everything as Unicode. So really, we in a sense, this isn't exact, but a good starting point would be to think of it as everything is considered a resource. Everything's equivalent. It's not open typed, because in open type, the computer has to waste a bunch of time figuring out what our type of thing is. It's not strictly typed. I don't write strongly. I'm sorry. That is called strictly typed. I'm not sure why I wrote strong there. It's not strictly typed. We don't have to say what we have and then stick with that and then manually remove it from our CPU memory when we're done with it. We're roughly treating everything the same. And in PHP, we're going to use the word resource for that. Everything we have is a resource. And for the most part, in loosely coupled languages, we'll recognize those because to set up our variables, all variables start with a $. So I was using X. So if we wanted the variable X in PHP, or really any loosely coupled language, we put a $sign beside it. So $sign means we have a variable, we have a resource, we can call it X, and then we can put whatever we want in there and change them back and forth. We can put the number 3 in there. And again, back to the C family, we do have to have the end of instruction every time. We could put the number, put our string in there, put words in there, and that'll be fine, and we can deal with it. Everything is approximately treated the same. A couple things we'll see coming up soon. We can put a file handler in there. C.txt. Open it for writing. We stick a file handler in there, and that's still a resource. So anytime we have a variable, with the PHP, it's a loosely coupled language, so we really want to think of everything as a resource. We kind of treat them equivalently. It's not strictly typed, but it's not really openly typed either. There are some restrictions and things we'll see that it's not fully an open type language, and it has a few advantages. Another one we'll see very, very soon is, when we store something, we could grab whatever is coming back across the network transmission. I'll just write something like this. There's stuff, we know that we're on the network. We know things are going to be coming across that network. So we're going to grab whatever is coming across that network under post protocol, as opposed to get protocol. Or we could just check the entire request all together. We'll see a lot of that soon. Main thing I wanted to mention is the $sign. That's kind of our keyword when we need to when we need to store something. I'll probably use the term variable a lot. Resource would be more technically correct for PHP, but for programming languages in general, we'd say variable. Anytime we want to assign something to a variable, we use the $sign to indicate we have a variable. The biggest disadvantage to that is the $sign has meaning. So if we need a $sign, we have to use an escape sequence, but it'll be the standard escape sequence. Whoops. This chalk's not good. If we actually want a $sign, we have to use the escape sequence, which is a backslash and then the $sign. Backslash is fairly standard in a lot of programming languages, especially the C family. Doing escape out of the code and put this symbol. Don't try to process that code. That's the big disadvantage of it. The big advantage of it is we don't have to use concatenation operator, right? So I'm just going to make up something for another language. If we needed to put a couple strings together, let's say, put the word hello in X and then a variable Y, put the word world, and then we can concatenate them together, usually a plus sign, the word stored in the variable X, plus the word stored in the variable Y. In PHP, I'll go ahead and mention it now. The concatenation is the dot operator. We use a dot for concatenation. We do not have to use that concatenation operator. In PHP, or really any of the $ languages, we can just put our words together. We can throw it right in the string if we have that $. So if X had the word hello stored in there, then when we go to store something in another variable for output where we're going to concatenate things together and just do it across several lines to keep the code looking nice and clean and easier to deal with and debug, we have that word stored there inside of a string with the $ on there. We can just put that variable right in the string and it will print it out. So since that's the word hello stored there, the output of that, even right inside the quote marks of the string, is going to just say output the word stored in there. So the biggest disadvantage is we need an escape sequence or a $. That's probably nice for programmers in Europe where they have the euro sign, but they might not have that on every keyboard anyway. And in America, we're going to use that symbol a lot. So, but it's not that big a deal. Just put a backslash when you actually need that. And the biggest advantage is we can just throw those variables right into a string. We don't have to, we throw resources right into a string. We don't have to do a bunch of concatenation. For single variables, when we have arrays, we still have to concatenate them. But we'll see that in next week, I think. But that's this is the main part for the background here. The C family, so that means every single instruction we pass to the computer needs a semicolon. And we need curly braces to wrap our group our instructions together, keep them connected. If, while, for, and switch are going to be the standard C family syntax. For those who have worked with C before, we'll see those very, very quickly. Thursday, we'll go through them and then we'll start using them in examples. Then PHP is loosely coupled, means we use a $ to indicate we have a variable. And that's pretty much what I had on this first set of notes for background information. Does anybody have any questions about that stuff? So you'd probably like to see some of this, right? Actually see what I was just talking about looks like. So let's kind of go through a little example here. Has anybody been able to get a localhost server up and going so far?
I think so.
Okay, so we're going to start doing. Yeah, I was thinking going to, leaving an hour of lab time. We probably want some stuff to do in lab time, so let's kind of look at I think we can take 20 minutes or so and kind of do a first pass of that discussion board. And then we'll come back and do it again on Thursday, but I think we have a few minutes where that way you'll have something to do when we get to lab time today. So I'm going to share my screen and pull up some code. So I'm going to use the localhost server. I mentioned that I use that free one I like. I'll go ahead and point it out to you. Those who had me for SDEV 153 the first 8 weeks, we use this because AWS is really, really slow approving my account. I applied for it in December still, and it was the beginning of the 4th week of the 8-week term when they approved my account. And then it took another week and a half to get the first classroom approved. So they move really, really slow. So I was brand new to it, and I didn't want to use it in class without doing that. So this one, infinityfree.net, it's free domain hosting. And this will work for everything we're going to cover in class until we look at chat rooms. But most every free domain host is going to try to block chat rooms because that really bogs down their chat rooms, really bog down their servers. But you can, if you want a free place to set it up that's easy to work with, you can just set up an account here. I like this one because it shows ads to the programmers. So there's features that we normally would have to pay for. You can just set up an account. It should be fairly straightforward. If anybody's interested in that, let me know. I have instructions typed up from when we used it in the last class.
So we can use the one we had last time still, right?
Yes. Yes. Yeah. Yeah, there's lots of places. We just have to have a server to run it on, whichever one you're most comfortable with. That server, XAMPP, that's what I've been using for years. It's just a basic Apache server. If you want to learn about servers, you have full access to do anything you want, and it's virtual. So if you full access to learn about it, and if you break it, just uninstall it and reinstall an unbroken one.
Okay.
Virtual stuff's nice like that.
So on that control panel, what are we going to turn on, or what are we going to start so that when we run our stuff, everything works?
So for right now, we just need Apache. So that's Apache server. And before the end of the semester, we'll need MySQL. I think we get there in week 5. And yeah, mine's set up so that both of those just start automatically. I'll go ahead and stop MySQL. But yeah, it should look like this. So just go ahead and hit start on the Apache server and wait for it to turn green.
And that's all I got to do, huh? And then when I run my stuff, it should work?
Yeah, so now you can leave this open or just go ahead and close it. And then you'll go to a browser. And the address for the machine you're working on is 127.0.0.1. That's the IP address of the machine you're on, so you can get there that way. Or you can type in the word localhost as one word. If you type in localhost, you should see this page right here.
Yeah, that part I got to work when everything is turned on.
Okay, yeah. So now, that means your Linux server is up and running.
So that tells me everything's running, so that if I do all this other stuff you're going to show us, it should work.
Yep. So you'll go to wherever it's installed. I recommend in those the little assignment thing I pointed out. I usually just put it on a C drive, in a folder on the C drive, and in there you'll see this folder called htdocs. And if you use most domain hosts, any Linux server for domain hosting, that should look familiar because that's where we post our stuff. So anything you want to show on the web page, you can put in that htdocs. So if you just go in that folder,
now,
right at the bottom, index.php, this is that index we're looking at.
Okay, so everything that I want to run on XAMPP, I put in that folder.
Yep.
Can it be in a subfolder of that folder? It has to be in that folder directly.
A subfolder is good. That was the next thing I was going to say. I like to keep the original index here because one of the common ways of interfacing with a MySQL database, if you don't want to just use text command prompt the whole time, is PHP myadmin, and that has a link to go right to it. And every time I try to type that, I make a typo. So I have to type that word really slow. So I always leave that index there. And I just set up a folder called My Pages here. And then this is where I'll put all the stuff for the course. This is where I'll work in it, a subfolder of the htdocs. And then to get there, you need a slash. So the address is like localhost / the My Pages folder. So it shows a couple things here. And since that's kind of buried, shortcuts are really useful. I did make a shortcut to that folder and put that over in my documents folder just to get there easier. You might want to think about that. Because most of us are used to opening the File Explorer and going to Documents, not opening File Explorer and going to C drive. So just making a shortcut and sticking it over here in the Documents folder I've found is really, really useful. So SDEV 253, make a new folder called class. And then in this folder is where I want to store PHP files. So I'm going to open a text editor, Notepad++. Has everybody used a text editor before? I see a couple names on here that I don't think I've had you all in class, but I assume you have a text editor you like, right? I think in the first 8-week course, well over half the class ended up using Atom. That's a very popular one. Sublime is very popular. I use Notepad++ because it has a view function, or a zoom function under view. Most of the text editors, I can't zoom in and out. It's not as big a deal here, but on campus, when we're in a classroom projecting it on a blackboard, being able to zoom in on some text was really, really important. But I'll just be using basic Notepad++. And I have predictive text turned off because I'm doing this so y'all can follow along. So I don't want that predictive text box getting in the way. But something that has that, it should recognize the language. So I guess we'll just do a most basic one. So just like our HTML tags, we're going to set up a tag. But in particular, we need a question, an angle bracket, a question mark, and then the word PHP. And you'll see in the textbook, there's different versions that will work. This is what I always use. Angle bracket. The question mark has meaning to the computer that we will see. We will talk about what question marks mean directly when we get to the Ajax section. So we'll talk about that. And then the style I use is I always like to put a question mark at the end just to help me identify which tag is the PHP. Because we can also intermingle that with HTML tags. I'll come back and do that in a minute. I just wanted to start with the basic one. So that's our tag, and any PHP we write in between there. So when we go to save it, just make sure it's a PHP file. So on most text editors, obviously it should be somewhere on the list, or you can go to language and choose PHP from here and go ahead and activate the lexing before you even start saving it. Personally, and what I'm going to do on the examples for those who haven't had me in class before is I'm just going to give it a name, and I just type in the extension to activate all the lexing and stuff like that. Oh, whoops, wrong folder. Make sure you navigate to that folder, to the folder there in the XAMPP folder. So I'm here on my pages, that's step 253. Our class examples, I'm going to call it day1.php file. So there we go with the lexing. Change colors. Not turn the predictive text off because as I type these examples, I expect people to be following along. So right off the bat, there's two ways we can send words back to the PHP file. So actually, let me put that on half the screen and that on half the screen. So right now, if I go in this folder, step 253, the class, so there's day1.php. Obviously, it's just blank right now. We need to send some words back to that page to show, right? So there's two ways to do it. They're almost interchangeable. We can either type the word print or the word echo. And on Thursday, when we do this in a little bit more detail, I'll talk about the difference between them, but they're virtually interchangeable. There's two small differences between them that we will talk about on Thursday. I'm going to use the word echo, and I will also use echo as the verb when I say echo stuff back to the page. If you prefer the print method, and you'll see the slight difference between them, on Thursday, you put print. Anytime I say echo, I use the word echo like a verb. But we're going to echo something back from the server to the client. And that's why I prefer echo instead of print. Because we're going to print stuff onto the browser page. So it makes sense that way. If we think about the entire process, I put this into the address bar in the browser on the client. So it made a request to the server, which is where this file is stored. I know it's the virtual thing locally, but hopefully that still makes sense. It made a request to the server, and then what we want the server to do is echo back something. I guess I'll start with just the standard. Echo back the words hello world, and it's the C++ family of languages. So remember the end of instruction character. So we're just the client's going to request this page, goes over to the server, and then the script on the server says, well, echo back hello world. So we hit reload. There we go. So that's how we get stuff onto the page. A couple of problems here though still, right? What's a good way to point at the first one? This is the web page. And everybody in this course had to have SDEV 153 as a prereq. If we pull up the page source, all we got back is the text, right? So do we have any way to style that text right there? Do we have any control over that text?
Not yet.
So in every echo that we do in this class, and really that you ever do with PHP, if it's echoing back to a web page, make sure you put your HTML tags in that echo. So it still looks the same here. I hit reload, but I go to view page source. Now we have HTML tags on there. So we can apply style rules, or we could give it an ID, or we could jump into JavaScript and say to do something specifically to every paragraph on a client-side script. But we can do stuff with that now. We have control over that. We have a way to control that text. So make sure, so keep that in mind. Every time you echo something back to the page, make sure you include those HTML tags. That's important. And well, I'll just do that example. I put hello world on the board, right? I stored the word hello into a variable. So instead of passing that in, again, we have resources, a loosely coupled language. So $ indicates we have a variable in X. And throughout this semester, right now, you might want to think, you're going to think $X every time you type that. When I go to type that, I think X, and I just type the two symbols. I've gotten so used to it. So when I'm talking about it, I'm going to say variable names and not mention the $. So throughout this semester, please remember that $, is there. That is a critical part of that code. It has meaning. But when I look at that, I'm going to say X. Because I don't even think $. I know I'm in PHP and just X, that means type $X. So that's what's going to flow out of my mouth when I'm talking. So I'm going to put into that the word hello. I can spell it correctly. An end of instruction. You got to remember the end of instruction character. Actually, I'll leave off the end of instruction character. And then instead of typing the word hello here, the dot operator is our concatenation. So with what you've seen in other languages, particular Python or in your SDEV 120 class using Raptor, we would bring in our concatenation operator, that variable, and then concatenate the rest of the string. So I'm going to reload this. There's going to be an error message right this time. It didn't give me an error message. I was expecting an error message, but there's ways we can avoid those. It's the very last line, so the computer was able to figure out where that was. I might have trouble if I do this one. Nope. There's not enough here for the semicolons to cause a problem, but they will. Yeah, I don't need it. Maybe if I do this. That one caused a problem. There we go. So that one missing a semicolon gives us an error message like this. So these are what our error messages are going to look like. And as we do our examples in class, I will usually throw the error message and talk about how to pull the meaning out of it. So something wrong with the syntax. So something went wrong with how we typed our PHP. The computer did not expect to see a variable. It hit a $. It hit something that is clearly a variable, and the computer did not expect to see a variable. Says the problem's on line 3, but we know it crashed right here where my cursor's at. So it had to have been before then. If we look back, you can see that missing semicolon. Oh, whoops. And don't forget to save the files. You have to save the changes every time. Save the changes and then hit reload. Okay, so now that cleared up that error message. But I'll be throwing lots of error messages in these. So that's how we store our data. And I'm going to take that line out. I just needed there wasn't enough there for the missing semicolon to cause a problem. It was able to tell where the instruction ended in that particular case, but it may not always be able to. So we'll see lots of those and deal with those. But we have that concatenation operator. With the $, we don't have to break out of our string and concatenate it. We can put that X right in the string. See how the format changed just a little bit on it? So just throw that variable right into the string, and the computer will still be able to determine what it is and put it in place. And that's what that first discussion board is about. So things about yourself. So I'm gonna put some stuff here about me to kind of show what this is, and we'll go back over this again on Thursday. So I'll create a resource called name, and I'll put my name in there. Resource called town. I live in Clarksville. And resource called pets. I have some goldfish in the other room. So just a few data points about me. And then those can be echoed back. So right now, just stored some stuff on the server. It doesn't actually make it back to the client. So to get back to the client, we need to echo some statements back. So echo back some statement. So whatever is stored in the name variable lives in whatever is stored in that town variable. And then a period for a grammatically correct sentence. And just build up the sentences that way. And for this discussion board, it will be perfectly okay to refer to yourself in third person. You don't need to go storing pronouns. So you can.
Did we not need to put the paragraph tags or the HTML tags on it for this thing, or what's going on?
Yes, we should. And that does go in the string. Yeah, I wasn't worried about it I wasn't as worried about it on the discussion board, but thank you, Joe. Yes, it does need to be on everything we do. Because otherwise, he is back. I'll wait for him to rejoin us. He must be having some internet trouble. And yeah, you having internet trouble? So I just kind of jumped in here. I think you cut out right. We'd already saved variables when it cut out of there. This is what I was looking for in discussion board. So in some have a variable where I store my name, and a variable where I store the town I live in, and just a few data points, and then concatenate together some sentences. And while you were gone, Joe pointed out that I forgot to put paragraph tags, even though I just made a big deal about that. And then just build up some sentences and do an introduction to yourself this way. So it doesn't have to be big fancy things. Short sentences like what's going on here. Chris lives in Clarksville. Chris has 4 pets. And with a tag. And just create a short introduction to yourself like this. Just a bunch of paragraphs. And if you want to start doing some styling and stuff, so the last thing I want to show here, does anybody have any questions about that? That's the idea of the discussion board. If you want to go ahead and start typing that up. So the last thing I wanted to show here then, if there's no questions, is we can intermingle this with our HTML code. Right? So that thing we always started out HTML code with. The doc type declaration, then the start of the HTML, then we have a head section, then a body section. And obviously those sentences are going to go in the body section. Then down here somewhere we can close out the body, finish out the HTML. So we're finished with that whole thing that makes HTML markup languages in general super efficient for machines.
Okay.
Yeah, every start and stop point in minutes.
But this is still a PHP type document, right?
Yes, it is still a .p.
So it's a PHP type document. That's its extension, but it'll have some HTML in it. Okay, so we still save it as a PHP. Okay, cool.
Yeah. So at this point, when I reload it, so HTML only displays. If we needed to do stuff, PHP has to. We need the PHP. It has to be .php to do stuff, because if it's .html, the server would send it to the client. if it's .php, the server knows to run the script. And yeah, and then
but it still has the doc type HTML stuff at the top, so that it knows that there's HTML in it.
Yes,
or
because
something.
we need all that, right? We need that head tag in order to apply some CSS here.
Cool.
And do like the paragraph. Any paragraphs get I don't know, background color of what's a good color? Something green. 23, 137, 32.
Oh, you're getting fancy. You're not typing green. Okay.
Yeah, I was trying to change it up. I know you also are used to me doing the words. Usually I'll do words for quick examples, but I wanted to go just a little bit further as a reminder. I know a couple people, it might have been more than a week since you had the SDEV 153 class. Okay. And then we'll do this at like.
And alternatively, I could have linked it to a style sheet, right?
Yes.
Okay.
Yeah, so that gives us a little bit. We get that styling information. We have that control with the markup language, and all the efficiencies that come with the markup language, because we have the thing that makes markup languages perfect for a CPU. Makes it harder for the human, but we have that start and stop point included in the data itself. Which makes it perfect for a CPU, better for a CPU, harder for a human, but all the advantages that come with having those tags and the controls that we get over them. And then PHP is kind of like another tag. And notice we have all of this stuff on the file. But when I go view the page source, or same thing in inspector, do you see a PHP file script, or do you see a PHP tag here on what made it to the client?
Nope.
So only the paragraphs. And so I didn't put any line breaks.
So all the PHP gets, it's not probably the right word, but interpreted. I don't think interpret's probably the right word, but
it is interpreted.
Okay.
That's what a command line means. So originally, that's what everybody liked about what this guy did, and why it has pretty much become the standard now, because it's command line like. It is interpreted line by line. Compiled means it translates the entire file into binary executable and then runs that file at once. Interpreted means line by line. It runs line 1, then goes back and runs lines 2. Then after line 2.
So it's like, as an example, if I'm interpreting with somebody speaking, as they speak. But if I was compiling, I'd have to hear the whole speech, and then I'd have to turn it into the new language.
Exactly. Yes. And that's why we can do this. If we had a compiled language, we could not intermingle with our HTML like this. We would have to have it in a separate file where we would compile that file. But here we can have some Unicode text that's just going to go back, and then we can suddenly have this thing that's just like, okay, oh yeah, here's some stuff to interpret. Here's some lines to interpret. It's going to run this line. And then after that finishes, then they'll take this line 18, convert that to binary, run that one instruction. Then line by line. So you were correct there. It is an interpreted language show. And that's what it has to be interpreted for a command line.
Well, I guess even a broken clock's right a couple times a day.
And yeah, that's why so many people like this, and people took to it quickly, because C++ was very quickly became the standard in the mid 80s, and a lot of people knew C++. And this guy thought of a way that he could intermingle C++ to HTML, which basically put what all the programmers already knew together. So then for 20 years, people just did their own thing and built thousands and thousands and thousands of libraries and functions, and pretty much anything we would want to do is already built in PHP. So there's a lot of checking reference material on PHP just to see what function does what we need it to do instead of having to type everything ourselves. But this is what the discussion board will be. Does that make sense now, Joe? Or anybody else? Does that make sense?
Perfect sense.
Yeah. So just and if you have me in other programming classes, I pretty much give this discussion board in every programming class. It's just that language, because every time we program, we're going to need variables, and we're going to concatenate together some output. So those are going to show up in everything we do. So we're going to jump in and do those two things right off the bat. And then the first during the first module assignment, there's kind of a review HTML section for those who haven't seen it in a while. Put together that form and that website. We're going to use that the whole time, but we're going to do everything manually. So there's going to be lots and lots of variables in module 1. There's going to be a whole lot of stuff. We get it set up, and then we're going to clean it up week after week after week and make it shorter and shorter. So part of that was just to get practice with the $sign thing. Getting used to putting a $sign everywhere, like not even thinking about it. Like when you look at this, you think name is the variable is called name, and you disregard the $sign, except that you know it as you just include it when you think variable. So there's going to be a lot of practice with that assignment. We'll talk about that, and module 1 assignment there might be longer than others. So we can I've already considered that we may need to push that due date back a little bit, make sure there's plenty of time to get a good start. But you should be able to go ahead and start putting together the HTML parts for it. Go ahead and put together a home page and start working on that form. And style it however you want. Like another level. Yeah, so I'll pull up from my practice. I went ahead and pulled out the first one. So the home page is just there to make it a site. We need more than the order form. Otherwise, it's hard to tell if the style lines up when we get that receipt and stuff. External style sheet, so everything can echo to it. And obviously, the home page can be HTML. If I click on this one, well, it's not up there anymore. You can see my order page is HTML. It's when I do the place, the buttons keep popping up. When I hit the place order, the receipt page is the .php. So we mix and match them. We don't have to have like everything on the site being a PHP site, a .php, or everything being a .html. You want to kind of organize it to what you need. But as far as the code that goes in them, if we can, as you see here, we can throw our HTML code right into that PHP. So hopefully that'll give you something to kind of get started with in lab time, and we'll jump in and see some other syntax or other operators where we can add and multiply numbers, and maybe the first couple functions on Thursday, get the AWS stuff started. Does anybody have any questions about that?
Yeah, before you totally sign off, if somebody was going to use the Infinity Free site to do some of this stuff, is there anything else I have to hit on the site to make it work on the site? Do I have to turn on other stuff, or do I just let it rip?
Well, I will do that real quick just to show you. So if I go to Infinity Free, it's because of WordPress. WordPress has probably become the most common way to put together web pages, especially for bloggers. There's a CMS site, and WordPress uses PHP 7 and MySQL databases. So everything we're going to do in this class is going to work perfectly out of the box on most domain hosts. Yeah, I wasn't exactly thrilled about all the setup we have to do on Amazon. Basically, we have to do some server admin stuff on Amazon ourselves. Every other domain host, we have this stuff right out of the bat. So if I just go to the file manager.
Okay. Oh, that's
I
right.
think I have a bunch of stuff here.
Okay.
I
I think it just hit me. So this thing's in an htdocs folder anyway.
Mm-hmm.
So that's why it works.
Yes. Yes. That's why.
And I didn't even notice that last 8 weeks. That's where we put our stuff. In
yes.
htdoc. Well, light bulb just went on. Hello.
Yeah. So exactly. I just uploaded it to that site. Yeah, this is one of those ones that, for those that weren't in the 8-week class, Monster is usually an expensive one to handle all our file transfers. But this site shows the programmer adds, so we get Monster on the free version. So yeah, I'll go to the site here. I probably have an index there. Yeah, I do. That / day1.php. There's that example again. And
if we've got some sort of index page already on our site, we can link an index to some of this stuff and boop, get to it real easy and bang.
Yep. Yeah. So this is the one. This is my favorite one to test on. So I have the localhost testing, and then this is the first place I go for online server testing before moving it to the final domains and stuff. Because this has a lot of features. If we go to the control panel, so for those who weren't in the first 8-week class, this is a nice, easy environment to work in. And until we look at chat rooms, everything else that we're going to look at in this course, it'll handle. Yeah. So because of this right here, show the programmer adds, and then it'll and that pays for some of the features that most domain hosts charge for. What's my ad for today? Universal APIs. Oh. Email, calendar. So here's some new programming plugin, basically. A way to tie emails and calendars and contacts into any program you want. A very, very useful thing, even for us. But if we look here, we have the file manager, and then right at the bat, we have the MySQL databases. We can set up that you have databases ready to go. Infinity free. Your restriction here, Joe, is you can only make 400 databases.
Only 400?
Yeah.
Oh.
Most free domain hosts only give you 3, but again, this place ties into targeted advertising, so that pays for a lot of things that normally wouldn't be on free ones. Makes it kind of nice. Got email servers, all that stuff just built right in. PHP is ready to go, and by default, I think it's over here on this list. Should be PHP 7. Oh, there it is. If you need to change it, you can go in and reconfigure it if you need to change it. There's AWS, so it's set up right off the bat, but AWS will make us set up the PHP configuration and set up the MySQL things. We have to do a lot more server admin stuff there, but AWS is huge. That old saying, you get what you pay for. There's a lot of truth to that statement. And AWS credits education stuff, so we might as well take advantage of those credits, right? And burn through some, I guess it's the school's money, and learn our way around AWS, because if we're going in this industry, we're going to need to know our way around it. That's why I went ahead and included it. But the free domain host sites, because of the popularity of WordPress, will do what we're going to do in this class right out of the box. Every one of them will. Any other questions? Okay, so it looks like 4:22. There's about 30 minutes left on our scheduled time, but that still leaves about 30 minutes of lab time. Most days it's going to be more like an hour of lab time. maybe longer sometimes, because it's an active subject. We learn by doing it. I'll talk about some of the concepts and stuff, but really it's when we sit down and write the code that we learn the best. So I'm going to make sure there's plenty of lab time every day. This will probably be the shortest lab session. Only 30 minutes lab session today. That'll probably be the shortest one, but that'll give you time to start either putting together the discussion board, and we'll look at that again on Thursday, like I said, or for the programming assignments, we'll use that same little story I made up, that same website we're going to use for the programming assignments every module. There's not one in module 8. So module 1, 2, 3, 4, 5, 6, and 7, we're using that same site. So if you want to go ahead and put the HTML together for that, then we'll do we'll see how to start seeing how to put the PHP together for it on Thursday. Do an almost identical example. I put the class examples together at the same time I put the weekly programming assignment together. But it's very similar to what the book has too. It's just the website sells something different, a different story behind it. Still interacts the same way. Otherwise, any other questions? All right, so I guess that'll be it for the lecture today. I'll go ahead and stop the recording, and I will be right here by my computer, the video set up here. The quickest way to get a hold of me is send a text message. Also got Ivy Learn messages, but for the past couple of weeks, they seem to take a long time to get to my phone. It's like a 45-minute delay from the phone, but hopefully that's going to come back around and fix itself soon. Maybe just somebody was on spring break, and hopefully the IT guy at the central office is back now and has whatever was causing that straightened out. But yeah, if you have any questions during lab time, just let me know, and I can jump back on here in a couple seconds time. Otherwise, I will see you all on Thursday. Everybody have a great afternoon.
Thank you, Chris.